Hello everyone, my name is Artem Zekov, and the topic of my today's speech is Immutability and Immutable.js library. And let's get started with the definition of immutable data. An immutable data is a data that can be changed once it was created. So here is a simple example of mutability of mutable data, specifically a native JavaScript array. We define this array variable of 4 elements, then we define this reverse array variable equals to our initial array.reverse method. And when we console.log this reverse array, we see what we kind of expecting. And unfortunately, when we console.log our initial array, we see that reverse method mutated our original array. And here we came up with the problems of mutability, problems of mutable data. Mutability makes our code unpredictable, and mutability makes our code harder to test. So consider this code. Imagine that you're working in a very big project in a team of, as a part of a team of developers, and each developer is responsible for specific parts of an app, and all parts are connected to each other. And let's be honest, your coworker may mutate something by accident. So for example, we've got this print reverse array function, for example, that was written by our coworker number 1. And it seems to be obvious that this function is just printing a reversed array as a given argument, but unfortunately, it can mutate our argument, specifically array, by accident. And moreover, for example, we've got this calcsum function, which seems to be just calculating the sum of a given array, but in fact, we can be sure that no magic happening inside there, that our array will remain unmutated. And well, we've got this problem of mutability, this problem of unpredictable code. And what is the solution for this problem? Well, you can't mutate a data structure if a data structure is immutable. So here is the same example, but with the use of immutable data structure called immutable list. We will talk about this specific data structure in further slides, but for now you just need to think of it as of immutable JavaScript array that can be changed once it was created. So we define this array variable as in previous example, and then we define this reversed array variable equals to our initial array.reverse method. And when we console.log our reversed array, we see what we kind of expecting, reversed array. And when we console.log our initial array, we see that it wasn't changed by reverse method. Reverse method didn't affect our initial array. And it's time to talk about mutability and immutability under the hood. So since talking about mutability, since in JavaScript variables just contain references to arrays and objects, any attempt to mutate their data, mutate them. And for example, if I want to change some value of this native JavaScript array, I just do it by reference, which means that I'm mutating an original data structure. And on the other hand, we've got this concept of immutability that where a data structure can be changed once it was created. And well, our data structure can be changed, but how can we get a new changed copy of it? Well, in order to change something, we need to create a copy of our data structure and make a change inside of it. So that is the way how we can change immutable data structure. And the main idea here is that any attempt to mutate an immutable data structure equals a new changed copy of it. Well, if any attempt to mutate an immutable data structure equals a new copy of it, let's have a look at this code. As far as I'm concerned, we're about to create 10 million copies of immutable lists, which seems to be bad to our performance. And I know what you're thinking. And this performance question brought us to this question: is immutability worth using it? Well, that's a good question. Let's check it out. So as we investigated before, copying wastes our time and memory space. But don't you have this feeling that there must be a better way? And there is a better way. Persistent data structures. A persistent data structure is a data structure that is able to save old version of itself. So let's have a look at how immutable data structures works under the hood. So we've got array from our previous examples, and let's represent this array as a tree data structure by putting all values into the leaves of the tree. This way, connecting them to the root node, and here we are represented our array as a tree data structure. And well, how do we change something? How do we update, insert, delete values? Well, in order to do this, we just simply need to make a copy of a node we want to make a change inside. So specifically, if I want to make a change inside this very bottom left value, and I just simply need to create a copy of this small node instead of copying the entire data structure. So here the idea that I'm making a small copy of a small piece of a data structure where I want to make a change instead of copying the entire data structure. So I make a copy of this small piece, make a change inside, and then connect this copy with remained data structure parts. So as you can see here, we reused 2 and 3 values, we reused 4 and 5 values, and we reused 6 and 7 values. In fact, we reused 75% of our initial data structure. That's called structural sharing, because we're sharing the structure of a tree between 2 versions of a tree. This concept of reusing unchanged data gives immutable data structures very good performance. So the idea is that old versions never change. They just sit and are. And new versions created efficiently with the help of structural sharing, of course. So now, since we're familiar with immutability principles, we can dive into the usage of Immutable.js library. And an Immutable.js library was created by Facebook, and it seems to be the most popular library nowadays. And here is some statistics of different immutability libraries in JavaScript in comparison with native JavaScript. And astonishing part here is that, as you can see, Immutable.js have very good performance according to arrays, and its object performance, it's not that bad. And all these performance results are possible with the help of structural sharing and concept of persistent data structures. So here is a list of the most useful data structures provided by Immutable.js library. We've got a list data structure that is alternative for native JavaScript array. We've got this map data structure that is alternative for native JavaScript object. And we've got this stack and set data structures. Let's have a brief look at the map data structure, and specifically its useful methods. We've got this constructor function, we've got this isMapChecking, we've got this set, get, delete methods, and we've got this to.js method, conversion methods. And let's have another brief look to the list useful methods and props, list data structure. And we've got this list constructor function, we've got this isListChecking, we've got this size property that containing list length. We've got this set, delete, insert, push, and pop methods. And the main thing that you should always remember while working with immutable data structures is that you can't mutate an original data structure. Methods such as set, delete, insert, push, and pop, they're not mutating an original data structure. They returning you a new changed copy of a data structure. And also we've got this to.js conversion methods. And now, since you're familiar with the immutability principles and Immutable.js library, you are able to choose from these 2 different options, from these 2 different approaches to creating your project. And I hope you will make a right decision. Thank you.